Hey everyone, and welcome to the first video in a new series of projects and tutorials where I'll be showing you how to use our 4D systems displays. My name is Tahir, I'm an industrial design student, and today for our first project, I've built a preamp with an audio visualizer using our Gen 4 ulcd 70DT. Let's get straight into it and I'll walk you through my process. So first up, I just wanted to plan out everything that I needed. So I made this document that lays out a template of what to include on each form. In Workshop 4, a form is basically one screen of your display, kind of like a page. Think of your phone. Your lock screen might be Form 1, your home screen is Form 2, and so on. It's a simple way to think about how your UI is broken up. So basically, my form breakdown is just in Form 0, just a title screen with an on and off button to start the system. Form 1, this is just the main screen. I've got a knob for volume control, an audio visualizer animation, and 3 buttons to jump to the EQ, input, output, and settings screens. Form 2, this page will have 6 sliders for adjusting the EQ. I'm using the smart slider feature, and I'll show you exactly how to set that up later. Form 3 is input and output. This screen just has a few buttons to choose your input and output, along with some LED indicators to show which ones are active. And finally, Form 4 is settings, pretty straightforward, just a few icons here for different settings. So the plan for this project is basically, as you can see, I have some of my records up behind me on the wall, and I have this record player. I basically just want something to go on this setup, on this little table that I built, that is going to complement it and look good. So with our display kits, there are a couple of different things that you get inside the box. Those being an SD card. Some displays also come with connector pins that you can solder onto the breakout board. A 30-way ribbon cable to connect to the display. Of course, the display itself, and depending on the model, there can also be a Wi-Fi adapter as well. So this is basically everything that you need to get started with your project. Today I'll be using the Gen 4 ulcd 70DT, which is one of our larger displays, and I'll just be connecting it directly into my computer by the breakout board through USB. Alright, so let's jump right into the Workshop 4 environment and get started with our project. So when you first launch Workshop 4, you'll see this screen. If it's your first time, the recent files section will be empty, otherwise you'll see your past projects listed here. Let's go ahead and start a new project. First, we select our display. I'm using the Gen 4 ulcd 70DT, which uses the Diablo 16 processor and is resistive touch. Once selected, the image will pop up showing the display. You can actually tap on this image to rotate the orientation that you want to use the screen in, if needed, but I'm just going to leave it as is for now. Then you'll be presented with 4 different working environments, those being Designer, ViSi-Genie, and Serial. You can read up on these more in depth on our website in our resources page. However, today we're going to be using the ViSi-Genie environment, so I'm just going to select that one. So now that we're here on the main page of Workshop 4, there are a couple of different things that you should check before starting your project. First, after plugging your display into your computer via USB, head over to the Comms tab and select the correct COM port where your display is connected. For me right now it's COM8. If the light here is blue and your display name is showing up, then you're all good. You can check what COM your device is using from the device manager in Windows. You also want to make sure that all the correct libraries are installed from our website, otherwise your computer will not recognize the display. So now that everything's set up correctly, we can move on to building our project. As we planned, the first screen is a simple title screen with a button. Now you can create this entirely within the Workshop 4 ViSi-Genie environment using built-in widgets. As you can see here, you can drag and drop labels or text, you can change the font, size, and placement all within the program. However, for me, I've made a graphic externally that I want to use instead. To bring that in, I'm just going to go over to System Media, then I'm going to drag in an image object onto the form. After that, I'm going to click the 3 dot icon next to the image path, and I'm going to choose my image from the File Explorer. Once it's loaded, it should pop up onto the screen, and now all that's left to do is resize it and position it wherever you want. So now the only thing that's left to do on this form is to create the button. To do that, I'm just going to head up to the Buttons tab, drag one onto the form, resize it and change the color to whatever fits my style. Next, I'll create a new form. Just go over to the System Media tab and add another form. This will be the next screen in our program, and we need to do this step now so we can link our buttons event to it. Now go back to the button you just added. Under the event section, set the onChanged event to Form 1 Activate. This basically means that when the button is pressed, the next form, Form 1, that we just created will load. Also make sure that the momentary setting is turned to no. What this means is that as soon as we press the button will react to our press. Now over on our new form, Form 1, which we just created, I'm going to start by making my own custom knob by using my own graphics. We're using the Smart Knob feature for this, so just drag the Smart Knob widget onto the form. You'll notice the square is empty at first. This is because the Smart Knob allows us to fully customize it with our own graphics. So I'm going to click on this button over here in the Config tab, which opens up the Smart Widgets editor. On the left side, you'll see where you can control the base image, and on the right side, you'll see where you can control all the layers that go on top of that. I'm going to import my base image, which is basically this gauge, and then import the knob image that goes on top on layer 1. A quick tip is to import all your layers before adjusting anything. This is because once they're imported, they get linked together, so scaling affects the other. Once they're in, I'll scale and resize everything to fit nicely and make sure that both of my graphics are aligned. Then I'll adjust the bounding box around the graphic just so that it doesn't take up more space than necessary. Now to animate the knob, I'm going to set the maximum value to 20. That's the number of frames that our knob will use during its rotation. After we're happy with our setup of the Smart Knob, we can close the Smart Widgets editor as we don't need to do anything else in there for the time being. The only thing left that we need to do is to make sure that we set the minimum and maximum values for our degrees. I don't want this knob to be spinning continuously in a 360-degree motion, so I am going to set my degrees to 45 and 315 respectively, just so it stops at the maximum and minimum volume settings. I'm also going to quickly make a title for this screen by going to Labels, adding a static text, and changing the font and the color to suit my design. So that's pretty much it for the knob. Now let's move on to the navigation buttons I mentioned earlier. First, I'm going to create 3 extra forms by hitting the form button 3 times. That way we have the pages ready to link our buttons to. Now create the 3 buttons on the main screen, just like before. The first one will be for the EQ, the second for the input, output, and the third for settings. I'll link each of the button's events to its respective form, so each one activates a different screen. We'll come back and add the audio visualizer to this page later, but for now, let's move on to building the EQ screen. Here on Form 2, we plan to have 6 sliders to control the equalizer. But don't worry, we only need to make 1, and then we can copy and paste it 5 more times. The process is really similar to the knob we made, except this time we're going to be using the Smart Slider feature for vertical Y-axis movement. So I'm going to import my base image and the first layer, align them properly, and set the bounding box size so everything's neat. Then, same as before, I'll set the number of frames to 20, but instead of changing the angle like with the knob, this time we'll change the Y-axis values to animate the slider going up and down. Once I'm happy with how it's looking, I'll hit OK and exit the Smart Widgets editor. Now I can copy and paste this slider 5 more times to make the full set of 6. I'll go ahead and label each one according to the frequencies they control, from Hertz to kilohertz, to make the UI more intuitive. Lastly, I'll add a home button at the top left corner and link its event to Form 1 Activate. This way, once you land on the screen, you can always head back to the main screen and you're not stuck here. Alright, now for the input and output screen. This one's pretty simple. We're just going to create 6 buttons labeled Line In, Line Out, Bluetooth, and AUX. Then I'm going to bring in some LED widgets and customize them to match the look that I want. Now if I link each button to its respective LED, the LEDs will turn on when the buttons are pressed. Super simple. Just make sure the buttons have momentary turn to no again, so they act like toggles when we press them. Also, I'm going to copy and paste the home button we made earlier from the EQ screen just to save time. Drop it in the same spot so you can return to the main screen from here too. Lastly, we have the settings screen. I didn't add any functionality to this one, it's just a visual placeholder. But if you want to add your own custom buttons here, you can use the user button feature. That lets you design buttons with your own graphics instead of using the styles that we have in the program. In my case though, I just added a few still images to represent what the screen could look like. You can always come back and expand on it later. And of course, make sure there's a home button on this screen too, so users can easily return to Form 1. Okay, so the very last thing that we're going to do is build these audio visualizers. So same as before, we basically just go into the config, put our face image or our base image, and then we put the image that is going to go on top of that. We then change our reference point to where we are happy with and the box size, and we change our y-axis value because this is only going to move on the y-axis up and down. So then we input the amount of frames that we want. For me, again, I'm just putting 20, and then you can scroll through and see this is how our animation is going to move. I'm just going to leave it at frame 5. It doesn't actually matter what frame you leave it on this time because we're going to code the animation, the bouncing of these sliders. So the first thing you want to do before we go ahead and actually code these is confirm their IDs. Their IDs being the number next to the name of the smart gauge. So this for me is 0 through 5. If you decide to change it, then those will have to be changed in your code reference as well. So back to Form 0, I have, starting off with MagicCode, this is our global code. And if I press this, you can see exactly what I've written here. So in MagicCode 0, I created a function called update visualizer that randomly assigns a new frame to each smart gauge, which creates the pulsing effect of the audio visualizer. Then in MagicCode 1, I basically just reset all the gauges to frame 0 when the system boots. I made sure to use a unique variable name to avoid workshop errors and conflicts. In MagicCode 2, I added a similar loop that resets all bars to frame 0 every time Form 1 is activated, just to keep the visuals clean. And here you can optionally disable the sliders, or you can also start another effect if you want. And then finally on MagicCode 3, this is the main loop. So I call update visualizer repeatedly, but only while Form 1 is active. After all of that, the visualizer runs automatically with randomized animation as soon as I activate Form 1. So it is constantly running while the screen is on. The CAD process for this build was relatively simple. Since all of the interaction for PREPULSE is touch-based, I wanted to keep the housing clean and minimal, just something that complements my existing record player setup. I started by sketching up a few basic forms and eventually settled on the design that you see as the final. To model it accurately, I used the engineering drawings for my display, which you can find for all of our products online by checking the datasheet. There are also step files available for every device, which makes the CAD process a lot smoother. From there, it was just a matter of creating the main base structure, cutting out space for the display and breakout board, and adding an exit point for the USB port so the flex cable stays hidden and isn't just hanging out the back. I also added some cutouts for magnets, which allows the faceplate to be removable, making it easy to access the display and electronics later in the event that I want to make changes. And just for a little visual flair, I extruded some text on the front face. Once all that was done, I sent my model into my slicing software and started the 3D print. I used Bamboo Labs' color painting feature to highlight the extruded text in orange to match the theme of our UI, and then it was just time for assembly. This is my favorite part. So I've actually made the tolerances tight enough to where I don't need to put the mounting screws in. Like, that is not going to go anywhere. In a normal or manufacturing case, you would obviously put the mounting screws and maybe make the tolerances just a bit less. But because I'm in full control of the process and I have my own 3D printer, it's really easy to dial in those tolerances to where it's like a nice snug fit, and that's not going to go anywhere, especially for our use case, which is it's just going to be sitting on the table. So for me, this is fine. If you have maybe a part that is getting more use than this or moves around a bit more, you definitely want to put in those mounting screws, and in a normal manufacturing process you would use those as well. So now with everything finished, all that was left to do was put it on my setup. I did make some minor changes after recording, but nothing really major to take note of. Thank you for watching, and I hope you enjoyed. Here's the final product.